Good afternoon, everyone. I'm Shelby, and today I'd like to talk to you about Virus X. Imagine a virus spreading across the United States. We'll call it Virus X. Each year, this virus infects 780,000 individuals and kills 31,000. Even if you do not contract the virus, just watching someone fall victim to it can increase your risk for long-term health effects, including increased risk for heart disease, lung disease, diabetes, hepatitis, and even stroke. Shockingly, this virus is completely preventable, and the main barrier to eradication is the United States government. You see, Virus X is not an imaginary virus. It is the epidemic of gun violence that is spreading across our nation. In 1993, Arthur Kellerman and his colleagues discovered that having a gun in the household increases risk for homicide. At this point, Congress passed the Dickey Amendment, which prevented the CDC from taking part in any research to prevent or advocate for gun control. The NIH faces similar obstacles. If these two major research facilities for public health cannot research this topic, who can? Enter me. My collaborators and I are currently producing a mathematical model to help address this problem. Mathematical models have been used to address disease topics since 1760 when Daniel Bernoulli produced a model of smallpox, and since these models have increased. Mathematical models can help to predict the rate of spread and the location of spread of disease, help determine eradication techniques, and also can help prevent initial outbreaks from occurring. Our model uses cellular automata, or CA, to observe the spatial spread of gun violence in Chicago, Illinois. As a basic of CA, we can see at the top that we have this lattice of cells, each in different states. For the purpose of this model, we can think of ones representing violence and zeros representing nonviolence. In each time step, the cells sum the neighboring contributions from the 2 to the left and the 2 to the right, and transition based on this table. So let's take the third cell all the way up there. From the left-hand side, we have a contribution of 1, while from the right-hand side, we have a contribution of 2. Remember, it's the 2 neighboring cells. So this overall sum of 3 means that it remains in the 0 or nonviolent state. But you can see that that's not the case for all of the cells. So our model actually has a lattice of cells that represent the blocks of Chicago, each with a different risk of violence occurring. At each time step, cells may change and increase or decrease that risk of violence occurring. We expand the basic model and look at how other factors, like the hardship index, seen here in this hatching, correlate with increased risk of gun violence events, which is the underlying heat map. Virus X is not imaginary. It is not something that is just in someone's head. It is gun violence, it is real, it is prevalent, and if no one else can work on it, we will.